Hello, dear students. We are studying the properties of sulfur dioxide. We have studied the reaction of sulfur dioxide with alkali. Now we are going to study about the catalytic reactions of sulfur dioxide. Sulfur dioxide reacts with chlorine in the presence of charcoal as a catalyst to give us sulfuryl chloride, which is SO2Cl2. So you can easily see SO2 gas reacts with chlorine gas in the presence of charcoal that produces SO2Cl2, which is also known as sulfuryl chloride. Sulfur dioxide is oxidized to sulfur trioxide in the presence of catalyst V2O5 or vanadium pentoxide. Sulfur dioxide reacts with oxygen in the presence of catalyst vanadium pentoxide to produce sulfur trioxide gas. This is one of the important reactions that is used in the preparation of sulfuric acid. This is a catalytic reaction of sulfur dioxide. Now we should study about the sulfur dioxide as a reducing agent. Moist sulfur dioxide reduces Fe plus 3 or iron 3 ions into Fe plus 2 ions or iron 2 ions, and sulfur dioxide is oxidized to sulfate ions. You can easily understand this reaction. Fe plus 3 reacts with SO2 in the presence of water. That means this is aqueous, this is gas, this is going to be liquid, this is again going to be aqueous, this is even aqueous, and H plus ions are also aqueous. So we can easily understand that Fe plus 3 aqueous reacts with, this iron 3 ions reacts with sulfur dioxide gas in the aqueous medium, and these iron 3 ions are turned into iron plus 2 ions, and SO2 is turned into sulfate ions, SO4 minus 2. How the presence of sulfur dioxide detected? This is an important question frequently asked into CBSE exams. If the given gas is passed through acidified potassium permanganate solution, and if the pink solution turns into colorless solution, the given gas is sulfur dioxide. So we can understand, or we can detect the presence of sulfur dioxide by the decolorization of potassium permanganate solution. Here the reaction can be represented as 5SO2 that reacts with 2MnO4 minus and 2H2O that gives us 5SO4 minus 2 plus 4H plus 2Mn plus 2. This is how the presence of sulfur dioxide gas is detected. Now, an important part we are going to study about it is the structure of sulfur dioxide. The molecule of sulfur dioxide is angular. The structure of sulfur dioxide we can represent is the resonance hybrid of two canonical forms. You can see the canonical form 1 in which sulfur is bonded to 2 oxygen, and with the first oxygen it has made the double bond, and in the second there is a single bond. It is very similar to this double bond undergoes the resonance, and between sulfur and first oxygen now we have the single bond, but there is a double bond in between the sulfur and the second oxygen, and ultimately we can consider it as the resonating double bond, and this is how we can represent the resonance hybrid for the sulfur dioxide. As the structure is resonance hybrid, the bond order between sulfur and oxygen is 1.5. So here the bond order is considered as 1.5 bond order. It's not a clear double bond. That is what we can understand. It is really interesting to study the hybridization or formation of 2 pi bonds in the sulfur dioxide. My dear students, it's really interesting to study about these 2 bonds formed here in the sulfur dioxide. We shall study them in detail into the next video. I hope, my dear students, you are enjoying your studies. Happy learning.